Hello everybody, welcome back to another YouTube video. In this video we will continue to talk about the properties of logarithms. In the previous videos we already looked at two rules about the logarithms. Now we're gonna take a look at four new rules in this video. Actually there are two new rules. The other two are derived from the other two of them. Let's take a look at the rules one by one. In number 3 it says the logarithm of x to the power of m in base a can be written as m times logarithm of x in base a. As we can see here, that m, which is the power of the number x, comes to up front and can be written as a multiplication. So here also we have other rules that we need to obey. For example, as we learned in our previous videos, the base should be a positive real number where cannot be equal to 1, of course, and m can be any real number. Let's take a look at an example about that one. For example, let's say logarithm of 8 in base 2 is equal to. We can write this expression as logarithm 8 can be written as, 2 to the power of 3, right? So we have the base as 2 and this is going to be equal to. Right now, the power of the number 2 is 3. And that 3 comes to the up front as a multiplied number. So this is going to be equal to 3 times logarithm of 2 in base 2. And as we learned in our previous videos, that logarithm 2 in base 2 is 1. So this is going to be equal to 3 times 1, where the result is going to be equal to 3. This one was about the rule number 3. Now let's take a look at rule number 4. Actually, it is very similar to rule number 3. Here the only difference is right now the exponent or the power is at the base. So if the power is at the number, that number comes to the upfront as a multiplication like we see here. But if the power is at the base, then actually that number is gonna come upfront as a dividing number. So for example, let's say logarithm of 3 in base 27 is equal to 27 can be written as 3 to the power of 3. So this is going to be equal to logarithm of 3 in base 3 to the power of 3. Right now that 3 is a power, as everybody knows, and it is at the base. So this is going to be equal to 1 divided by 3. So that 3 comes up front as 1 divided by 3 times logarithm. I'm writing the rest of the logarithms. Logarithm of 3 in base 3, and as we learned before, this is going to be 1. So this is going to be 1 divided by 3 times 1 is 1 divided by 3. Okay, now let's take a look at rule number 5. Actually, rule number 5 is a combination of rule number 3 and rule number 4. Let's take a look at an example. For example, let's say logarithm of 27, the base 27, and the number is 81. So this is equal to what? Let me write it here. This is about rule number 5. And now, in such questions, always think about the numbers, the common number that base and the number has. For example, 81 can be written as, this 81 can be written as 3 to the power of 4, and that 27 can be written as 3 to the power of 3. So we need to always find a common number between the number and the base in a logarithm, just as a clue. So that expression can be written as logarithm of 3 to the power of 4 and the base is 3 to the power of 3. And that expression is equal to, as we learned in our previous properties, that 4 can come up front as a multiplied number. So this is going to be equal to 4 times that 3 can be written as 1 divided by 3 times, and the rest is logarithm of 3 in base 3. And everybody knows that, whoever watched this video of course, this is going to be equal to 1. So this is 4 times 1 divided by 3 times 1 is 4 divided by 3, which is the final answer. And if you look at the 6th property, actually it looks like the 3rd property. It is just slightly different from number 3. For example, let's say logarithm of 1 divided by 125 in base 5 is what? This is equal to logarithm 125 to the power of negative 1. And the base is 5. So that negative 1 comes in front of the logarithm. So it's going to be negative 1 times logarithm of 125 in base 5. This is equal to 125 can be written as 5 to the power of 3. Okay, 125 is 5 times 5 times 5, which is 5 to the third power. Negative logarithm 5 to the third power in base 5 is, again, that 3 comes up front. So it's going to be, because there is also a negative sign, so it's going to be negative 3 times logarithm of 5 in base 5. Logarithm 5 in base 5 is 1. So this is going to be negative 3 times 1, which is negative 3. Okay, this is the final answer. Now let's take a look at some challenging questions. Here we have logarithm of 9 in base 3 plus logarithm of 125 in base 5, and logarithm of 1 divided by 7 in base 7 is equal to what? As I said at the beginning, okay, try to make a connection between the base and the number, okay? 9 can be written as 3 to the power of 2. So let me write it here. Logarithm of 9 can be written as 3 to the power of 2 in base 3 plus. Logarithm of 125 can be written as 5 to the power of 3 in base 5 plus logarithm of 1 divided by 7 is 7 to the power of negative 1, where the base is 7. Now this is equal to, okay, that 2 comes in front of the logarithm, that 3 comes in front of its logarithm, and that negative 1 comes in front of its logarithm. So the whole expression is equal to 2 times logarithm of 3 in base 3 plus 3 times logarithm of 5 in base 5 plus negative 1 times logarithm of 7 in base 7. Logarithm of 3 in base 3 is 1. Logarithm of 5 in base 5 is 1. Logarithm of 7 in base 7 is 1. And the numbers which are in front of these expressions are, the first one is 2 plus, in the second term we have 3, because there is a plus sign and there is a negative sign. If you multiply a plus by a negative, then the result is going to be negative, of course. So it's going to be negative 1 times 1. So this is equal to 2 plus 3 minus 1, and that makes it 5 minus 1, which is 4, of course. Now let's take a look at the next example. Logarithm of 4 can be written as to the power of 2, and everybody knows that square root of 2 is equal to 2 to the power of 1 divided by 2, right? Because here the power of 2 is 1 and the degree of the root is 2. So that expression is 2 to the power of 1 divided by 2 anyway. So it's going to come to the base part, 2 to the power of 1 divided by 2 plus logarithm of 5, and the base is 5 to the power of 1 divided by 3 plus logarithm of 3, and 1 divided by 9 can be written as, okay, just let me write it here. 1 divided by 9 is 1 divided by 3 to the power of 2. This is also 3 to the power of negative 2, guys. So that's going to come to the base part here, 3 to the power of negative 2. And it's going to be equal to, again, that 2 is going to come to the front as a multiplication 2 times. Okay, that 1 divided by 2 is going to come as a denominator, okay? So it's going to be 1 divided by 2 times the rest is logarithm of 2 in base 2 plus. And that 1 divided by 3 is going to come to the denominator, so it's going to be 1 divided by 3 times logarithm of 5 in base 5 plus, and that negative 2 is going to come to the denominator again, 1 divided by negative 2 times logarithm of 3 in base 3, and this is going to be equal to, okay, if you 1 divided by 2 is what? 1 times 2 divided by 1, which is 2. So from here we have 2, so it's going to be equal to 2 times logarithm 2 in base 2 is 1, plus the same thing is going to be applied here, okay? So it's going to be 3, of course, times logarithm of 5 in base 5 is 1, minus 1 divided by 2 times 1. So here we have 4, plus from here we have 3 minus 1 divided by 2. 4 plus 3 is 7. So it's going to be 7 minus 1 divided by 2. 7 times 2 is 14. Okay, just let me write the result here, which is equal to 13 divided by 2, which is the final answer. Okay, this is gonna be our last question in this video. As I said before, always we need to make a relation between the number and the base, guys, in order to solve these kind of logarithms. For example, here in the first term we have 2 square root of 2, right? So 2 square root of 2, we need to find a way to write it 2 to the power of something, and that 2 can go inside as 4, or 2 to the power of 2 times 2. This is gonna be equal to square root of 2, because the bases are same, so we just add the powers in such a multiplication, guys, and this is gonna be square root of 2 to the power of 3, which can be written as 2 to the power of 3 over 2. So in the first term here we have logarithm of 2 to the power of 3 over 2, where the base is 2, plus logarithm of, again, 1 divided by 25, I'm talking about the base, can be written as 5 to the power of negative 2, and 625 is 25 square, or 5 to the power of 4. So this is equal to logarithm, before logarithm actually, that 3 divided by 2 comes up front as a multiplication. So it's going to be 3 divided by 2 times logarithm of 2 in base 2, plus that 4 comes as a multiplication up front. So it's going to be 4 times that negative 2 comes to the denominator, so it's going to be 1 divided by negative 2 times logarithm of 5 in base 5. As I said, in such questions, always try to make a connection between the number and the bases. Why? Because we can benefit from the property that if they are same, then the result is going to be 1. The value of that logarithm is going to be 1. So it's going to be, this is 1, and that part is 1 as well. So it's going to be 3 divided by 2 times 1 is 3 divided by 2, plus that part is 4 divided by negative 2, which is negative 2, guys. I'm not talking about I'm not writing logarithm 2 in base 2 and logarithm 5 in base 5, because we already said that these are 1. So the leftover is 3 over 2 minus 2 is what? Negative 2 times 2 is 4. So it's going to be 3 minus 4 divided by 2, which is negative 1 divided by 2, guys. Let me write the final answer here, negative 1 divided by 2. We will continue to take a look at the properties. Thank you for watching, and see you guys in the next video.